Welcome to Chapter 7, the last chapter of the NFV 101 course. This chapter is perhaps my most favorite chapter because it talks about future trends and what NFV is going to enable as we move forward. Cable is poised for the future with by far the best access network. So that's a huge strength that the cable industry and cable operators have going into this new world. There are three things that I believe cable operators have to look forward to with NFV. First is technology evolution. High bandwidth DOCSIS networks, multi-gigabit capable, will provide the best-in-class access platform for network evolution. So that's a very strong starting point for cable operators. Using the starting point, cable operators can leverage it in two ways. One is for revenue growth, new applications that require high bandwidth and low latency. They could be consumer or enterprise services, and those will definitely create a whole host of new services and new service revenue for cable operators. And this technology evolution combined with NFV can also be leveraged to get cost reduction. So NFV and SDN will enable automation, commodity hardware, improved efficiency, improved hardware utilization, faster time to revenue, and new procurement models, business models, all of which will contribute to cost reduction. So given these three, what does the cable industry have to look forward to? So where can NFV and SDN take you? It can help generate new services and revenue in four areas: consumer, mobile, business, and IoT. We've talked about all of these in quite a bit of detail already, so I'm not going to go through the whole list of services again, but I think one key item to point out is we actually don't know what services are going to be rolled out in the future. We can't even imagine what services will get rolled out, what services will catch on, and we can only dream. So on the consumer side, see the CableLabs The Near Future video. It's on YouTube, and that'll give you a glimpse of video and other services that we have yet to imagine. On the mobile side, we talked about the carrier demo that exists already, and again, there could be things like seamless roaming between fixed, mobile, and Wi-Fi, and other services that we are yet to imagine. On the business side, we talked about SD-WAN, virtual CPE type services. Those could be extended with network slicing, etc., to provide on-demand services optimized and tailored for a customer's individual business needs. And IoT, I think there's just going to be a tsunami of new services, new and exciting services. Talk about smart cities, factories, smart buildings, autonomous cars, and a whole host of new things that we are yet to imagine. At this point, it's useful to take a look at NFV in the context of a timeline. We talked about a lot of sophisticated and new technology, and it's going to take some time for the industry to absorb this new technology. It's not going to happen overnight. In fact, we feel it'll happen over perhaps a 6-year period in 3 distinct phases or waves, and let's look at the 3 waves in more detail. So the first wave is lift and shift, where you take an existing physical network function, PNF, and you convert it into a VNF. So that's a monolithic VNF. It's a basic building blocks. A lot of solutions will be single vendor solutions because interoperability will not be well established at this point. It takes a long time to onboard VNFs, and 9 months is not unusual, and the amount of automation is very limited. So that's where we are today. The economic benefit is to reduce data center capex. That's the main benefit of NFV today. In 1 to 3 years, we expect a move to cloud native. We talked about Kubernetes, we talked about cloud native methodologies, and we will see an adoption of traditional de jure and de facto standards. And we've talked a lot about standards based on open source, on standard bodies and then open source. So we expect to see that. Container-based implementation, decomposition of complex VNFs into multiple pods, which then consist of multiple containers. Due to standardization, we expect the time to onboard VNFs to shrink from 9 months to roughly, say, 1 month. And there will be multiple conformance and verification programs available through a number of institutions and organizations. And the economic benefit of this phase is to have competitive software. And the last phase, 3 to 6 years, is to have autonomous networking, complete automation. We will see a convergence of cable access networks. We will see full DevOps and artificial intelligence, machine learning techniques to optimize the networks. DevOps means continuous integration, continuous testing, continuous delivery, and continuous monitoring. So we will see that entire loop fully implemented. We will see AI and ML to predict performance issues, predict traffic bursts, predict capacity planning issues, etc., and faults. We will see end-to-end automation. The prediction engine, the analytics engine will directly drive orchestration and lifecycle management to see an end-to-end automation of network services. That will result in self-healing networks, self-optimizing networks, and the economic benefit at this stage will be full convergence. So I'm not going to sugarcoat it. The NFV transformation is not easy. It's going to be long and in some cases bumpy road, where there'll be a technology component of the transformation exercise and a non-technology or a non-technical aspect of NFV transformation. CableLabs can help with both. On the technology side, CableLabs can help with software. We looked at snaps. It can help with training and skills, and this is just the first example of the CableLabs training. Applications and demos, we looked at one specific demo that Curio has created. There are others that are in the works. Industry engagement in terms of working with standard bodies and open source organizations. And interoperability, again, we touched on that with Curio. So that's what CableLabs can offer on the technology side. On the non-technical side, CableLabs can help with best practices. So TCO modeling. You saw a lot of results from a lot of work done on VCCAP core and RPD TCO modeling. Standards work, open source, and platform architecture, whether it's for SDN, NFV, edge, security, etc. All right, congratulations, you've completed the course. Let's take a moment to go through what the original course objectives were and see if we accomplished them. The first objective was to understand NFV and the key topics surrounding it, which we did cover. We then looked at the overview of the industry landscape in terms of open source projects and open standards. We took a look at NFV use cases with a specific focus on 3 to 4 cable-centric applications of NFV. We saw how CableLabs is taking leadership in both open standards and open source software around NFV. And we took a look at some future trends. We do have some suggestions on what you may want to do next after this course. First off, please try snaps in your lab. You saw the various flavors of the snap software, and you can install it in your lab. You can try out VNFs and experiment. Next, collaborate with CableLabs on use cases, interoperability, and performance requirements. You saw the various initiatives from CableLabs, and we'll encourage you to reach out and to collaborate. Next, please take a survey. It's a really quick 3-minute survey that'll help us get feedback on this course and plan out additional courses like these. Thank you.